Good day everyone, my name is Graphics. In this video, we want to solve a problem involving circuit theory. We'll be looking at a supermesh. If you look at the problem that is displayed on the screen, it is a circuit that has 3 mesh and 8 elements, in which 5 of the elements are passive elements and 3 of the elements are active elements. The passive elements are the resistors, which has resistances of 6, 2, 10, 4, and 1 ohm respectively. And the active elements are the source, the voltage source, and the current source. We have 1 voltage source here and 2 current source here, right? Now let's say this is point A, B, C, D, E, F, G, and H respectively. And we know each of this mesh has, this circuit has 3 mesh, right? Which is I1, I2, and I3 respectively. Now, since this is I1 here, it means I1 is flowing through A and B, part A and B, right? Flowing in mesh 1. I2 is in between B and C and it's flowing in mesh 2. I3 is here and this is flowing in mesh 3, right? Now, if you look this closely, our 6 ohm current source is in between 2 mesh. Our 6 ohm current source is really what? In between 2 mesh. That is why we're calling this mesh a super mesh. Whenever you see a circuit and you discover that a current source, whether dependent or independent, is in between 2 mesh, you call that kind of mesh a super mesh, right? And we cannot solve it the way we solve other problem that doesn't have a current source in between 2 mesh, because this current source here now is now restraining us from getting the given equations that will help us in getting the current, both the branch current and the mesh current in this given circuit. So the question is, what are we going to do? What we are going to do here is that we are going to open circuit the 6 ampere current source. And when we do that, it will now stop the flow of current in between the parts BG, meaning that if I open circuit it, meaning that what is the same thing by me removing the entire element I have on that branch there. So my new circuit will now become like this if I redraw it, right? So I still leave my B here and G here, every other thing remain the same, right? The B and G I leave there to make you understand that what there's something on that part that I've removed. So my I1 is still here, my I2 is still here, right? My I3 is also still here. Is that okay? Now what will I now do? I will consider mesh A, B, C, F, G, H, A, right? And when I consider that, and I will take this, my negative to be the lower potential and my positive to be higher potential. So I will take when current move from lower potential to higher potential, the voltage source there will be what? Positive, right? So I'll be having 20, and if the voltage source is positive, right, meaning my voltage drop will be what? Negative. Mark that word very well. If I move from lower potential to higher potential and I'm taking my voltage source to be what? Positive. That means when current now flows through my resistor, my voltage drop will be what? Negative. But if I take my current source to be negative, when current move from lower potential to higher potential, my voltage drop will be what? Positive. Is that taken now? So your voltage drop can be negative or positive depending on what you've taken your voltage source to become. The main source that supplies current into the circuit is the voltage source. The voltage drop is when current flows through a resistor. There's a voltage drop, and that will give us what? It can be negative or positive, or call it a what? A voltage drop. So let's move forward. So if it moves from lower potential to higher potential, we're taking the voltage source to be what? Positive. So when current now flows through the resistor, the 6 ohm resistor, right, and the same direction as direction of what? Of my current. I'm moving in the same direction because I'm going in a clockwise direction. So I'm moving in the same direction as direction of what? My current. So I'll be having the negative, right? Negative what? 6I1. That is the what? The voltage drop. Why is the voltage drop? Because the 6 is the resistance, the I is the current. I will know that current and resistance will give you what? Voltage. This is what I've already explained in my previous video, which if you are patient enough, at the end of the video I'll be dropping the link of how to take mesh analysis of a given circuit, right? So let's proceed. Now if I now move to the next stage here, what is flowing through the 10 ohm resistor there? That is what? I2, as you can see. So it will be negative what? 10I2, since we are still going the same direction as direction of the what? The current. Now we'll go to the next one. In this part here, since they are sharing one boundary, I2 and I3 are sharing one boundary, we say the current that is flowing through this part here is what? I2 minus what? I3, right? So we'll put negative. So it means that the I2 and I3 are current, right? And the 4 is resistance. So when you have current and resistance, you have a voltage drop. So it'll still be negative. So into bracket, I2 minus what? I3, the 4 is there, equals to what? 0. Now if we proceed, we'll be having 20 minus 6I1 minus 10I2 minus 4 times I2 give you minus 4I2 minus 4 times minus I2 give you what? Plus 4I3, right? Equals to what? 0. But we'll take my I3 to be what? Negative 5, because you see the current source here. So the current flowing at this part here, you can see, is what? That is I3 flowing here. So the I3 here is what? The current source here, which is what? 5. But since we are going in an opposite direction, look at the arrow of the current facing up, and we are going what? We are going clockwise, while the current is coming anti-clockwise. So that's why we're having negative 5 here. Is that okay now? Now when I put it in my value at here, I'll be having 20 minus 6I1 minus 6I1 minus 10I2, 20 minus 6I1 minus 10I2 minus 4I2 give us what? Minus 14I2. And the 4 times minus 5 will give us what? Minus 20. This is what we have here, right? Now, if you see the 20 will cancel out the minus 20, we're left with what? Minus 6I1 minus 14I2 equals to 0. And if I take it to the other side, it's still same as saying 6I1 plus 14I2 equals to 0. That is my equation 1, right? Now, we'll now move forward. We'll now apply KCL to node B, because you see node B here, we're seeing here. So we're applying the KCL, which is the current law that says the current entering the node is equal to what? The current leaving the node. So if you look at I1 here, what's it doing? It's entering into node B, right? Then plus, look at 6 is also entering node B, equals to the one leaving. So I1 and 6 are entering, then I2 is leaving. That's why the I2 is in the other side of the equation, right? So if I make I1 and I2 as the formula, I'll be having I1 minus I2 is equals to what? Minus 6. I'll call it equation 2. So I'm going to solve equation 1 and 2 simultaneously, right? So if I solve them simultaneously, I'll be having I1 minus I2 equals to minus 6, and also be having 6I1 plus 14I2 is equals to 0. So these are the two equations that we're having here. Is that okay now? So if I solve them simultaneously, I will, using elimination method, I'll make the equation 1 to be equals to what? The equation 2, right? That is the equation of I1, they should be equal. So if I multiply equation 1 by the equation of I1 in equation 2, I'll be having 6I1 plus 14I2 equals to 0. So I'll be having the same thing because it's 1 I'm using. That'll be my equation 3. And similarly, if I multiply equation 2 by the equation of I1 in equation what? Equation 1, right? Which is 6. I'll be having 6 times I1 give you 6I1. 6 times minus I2 give you minus 6I2. 6 times 6 will give you what? Will give you 36. That is minus 36 that I will have here. So if I subtract both of them, the main reason why I'm subtracting both of them is to equate one of the unknowns, since we have two unknowns. If I put my negative sign, you see that 6I1 will equate 6I1, we're having 0. Then 14I2 minus minus, because this is a minus here and this is another minus here, right? Will give you what? 20I2. Because minus minus is plus, so 14 plus 6 will give you what? 20. Now 0 minus minus, this minus here and this will give you what? 36, right? So I2 will now be equals to 36 divided by 20, and we'll be having what? 1.8 ampere, right? That is my I2. So what will I do? I'll put my I2 into equation 1 or equation 2, any one of your choice. So if I input I2 equals to 1.8 into equation 2, I'll be having I1 minus I2 is equals to what? Minus 6. I1 minus 1, I2 is what? 1.8. So I'll be having minus 1.8 equals to minus 6. So my I1 will now be equals to what? Minus 6 plus 1.8, because minus 1.8 is coming to the other side of the equation, becomes plus. So this will now give us minus what? 4.2 ampere. So it means that my I1 is what? Is minus 2 ampere. The negative is telling us that what? The direction of I2 of I1 is not supposed to be moving the way it is moving. It's supposed to go the opposite direction, right? Your answer is correct, but the negative is telling you that what? You need to change your direction. And I2 is what? 1.8. So this is what we have here. We already have the I3, which is what we say it is what? Minus 5 ampere. So this is what we have. This is how you can calculate question involving what? Super mesh, right? Remember, the only time you can use a super mesh is when you have a current source in between two mesh. Is that okay now? And if you want to access other questions on mesh analysis, you can actually click on the link at the top right corner of the screen. It will assist you to enhance understanding on how to take what? Calculate for current in a mesh, right? So if you have found this solution helpful, please don't forget to like, subscribe, comment. If you have any question, just comment on the comment section. Thanks for watching.